Hello everyone. Today we are going to solve today's LeetCode daily problem. Let's see and find it here. Let's see what is today's question. Today's question is problem number 2078. Two furthest houses with different colors. It's easy question. What it says that there are in houses evenly lined up on the street and each house is beautifully painted. You are given a zero index integer array colors and of length n, where colors of I represent the color of the ith house. Return the maximum distance between two houses with different colors. The distance between ith and jth houses is absolute of I minus j. Okay. So basically, it's a very easy problem. Like we have to just found like two farthest most houses whose colors are different. Like here, color is 1 1 1 6 1 1 1, and this 1 and 6 are the farthest. So this will be the answer 3. Here also like first and last houses are of different color. So uh, what is the like limit here? We can see the size of the color is 100, so we can definitely do brute force here. Like we for all possible pairs, we will just check if the color of the houses are different. We will just compute the answer. So for that we do just size color size. Then the answer is 0 initially, and we will just do some loop and j will go from I plus 1, j less than n, and j plus plus, so that the pointer are different. Now, if colors are different for two houses, if colors of I not equal to colors of j, then we will just maximize the answer, max of j minus I. We're not taking absolute here because j is always greater than I. So, and lastly, we will just return the answer. So it was basically very easy problem. It should pass the samples. If I submit this, it should pass in all the test case. Yeah, it got accepted. So, so basically, what is the time complexity here? If I see time complexity is basically we are just using two simple for loops. So time complexity is order of n square, and space we are not using any space. So space complexity is order of 1. So these was for today. But like we can think this problem like what can be it harder version, like if this range is not 100 but instead of 10 to the power 5 or 10 to the power 6, like is there any better way to approach this? Can we reduce this time complexity and space complexity? So if we look carefully, like this problem is like very can be intuitively solved like with two pointer. Like if you see carefully, the answer always exist in some end, uh, like let me open my one no. So if you look carefully, what I'm claiming that if like the array is something like the color are A, B, C, D or something like A, B, C, B, D or A, anything, the answer always exists from an end. Like answer can be from starting to some distance or from ending to some distance. The optimal answer cannot lie in between. Like uh, the answer cannot be like this in the between. So how we can like show this intuitively, like why the answer cannot be lie between in between the array. It must be like either start from the starting of the array, like in the answer, one of the houses either situated in the first or in the last. So let's see it intuitively. Like if the answer, suppose answer exists in the middle. Okay, so obviously the first and the last color, like the color before this and the color after these houses must be same. Like if these are different, then there the answer, if like this is B, then answer will be this, no, not the in between. So if this red one is the optimal, then obviously this color are same. Now for these two houses, we know that if this is a optimal answer, these two houses must have to be different, they cannot be of same color. So there are two choices, either like one of them are color with same color of these, like one might be A and other have to be different, so other, let's say it is B. So in this case, you can see there exists a better answer, like from this starting A to this B. So instead of this optimal answer, we can take this better answer. And for the reverse also, if this is B and this is A, then also we found a better answer from this B to this A. So this rate cannot be optimal if one of the color is the same as other. And another thing can happen, like these two houses are completely different from these outer houses. Let's say these are sorry for the handwriting, B and C. If this is B and C, in that case also, like there exists better answer from starting to this C or from this B to last day. Like whatever will be maximum distance, that will be the answer, which is mm, uh, greater than this red one. So we can intuitively show that in any case, like in all the possibilities, the answer cannot lie between the array. the the two houses which are optimal, they must have to, like one of them must have to lie either in the front or in the end. So what we will do, we will just come, like to calculate this, we know that there might two cases. From the first house, we will find like from the right side which one is different from this and calculate the answer once. And similarly for the last house, for the last house, we will come from the first and find the first one which is different from it and calculate the answer, and we'll return the maximum of these two. So in this case, what we will do, we will use two simple loops. Like for one will be the from the first, like from 0 to n I plus plus. And also in the question, it is guaranteed that at least two houses have different colors, so it will work for in that case. So what we will do, if like colors of I is not equal to the last house, like colors of n minus one, then we will just calculate the answer equal to we will just assign the value that last house is n minus one minus current house is I, and we will break. Like for the last house, these have to be the like farthest most left will be the optimal for the last house. Like for this house, if we go from the first whichever will different, that will be the optimal. Like that will be in the maximum distance. Similarly, for the first house, we will came from the last, and whenever we will first encounter any different value, that will be the optimal for that. So now we will come from the very end, and similarly, if colors of I is not equal to colors of 0, which is the first house, we will just maximize the uh, answer from a like I, because basically I minus 0, which is I. So if we run this should also work. Uh, okay, I have not, but you're submitting too frequently. Okay, so it passed on the sample data. So let's test on the main test cases. Yeah, it passed. We can use the break here. That will also work. Like so now if I see what is the time complexity, like here we are using two pointer approach, kind of like using two pointer, fixing one pointer to one end and then traversing other pointer from a different direction, and whenever we will find like the first different color, we are just calculating the answer. So here for this we are using just two simple linear loops. So in that case the time complexity here is order of 2n. Like we are using two simple loops, which is nothing but order of n, linear time complexity, and we are not using any extra space here. So the space complexity is order of 1. So from quadratic time complexity we reduce to linear. So this is the optimal solution you can use. So here this is a easy question, so you can use either brute force or this. But for the harder version of this one, you have to use this two pointer approach. So let me know in the comment like uh, have you noticed this thing that the answer, the one of the houses must have to be like in the end, either in the first or last, or you just solved it in the brute force way. And yes. So let me know in the comments. So thank you for today. See you. Bye bye.